Hello, Mr. Price here, and this is question 4 of the Jan 2006 M2 paper. And this one is a centre of mass and a little bit of moments as well on this question. The two normally go side by side. Okay, so we have our rectangular frame, which consists of 4 uniform metal rods. Okay, so it's a frame, it's not a solid piece of metal. We know the distances of these. And this frame is being held horizontally, so if you imagine the frame is kind of going to be this way. I know it's hard to see the diagram on the video there. And these hinges are supporting it. And the first question is asking us to draw a sketch of the directions of our horizontal components of these hinges. Okay, horizontal components, so going in this direction. So this one's not too difficult if you know what you're doing. So, for part I, here is our plate. And here it's a good idea just to get something and model what's going to happen. So if this is your plate and it's being held like this, I'm having to do this flat, so you need to do this more in this orientation. Now, if you let go of this one, you should find that the hinge is going to want to start rotating this way. So this hinge is providing this motion to stop it from going this way. Okay, so the bottom hinge is providing a force to the right, and if you do the same for the top hinge, it's also going to want to start to tilt downwards. So this top hinge is pulling it back. So this one is going in this direction. And that's all you need to do for part I. That's it, job done. We've sketched a diagram with the directions in a horizontal plane. Okay, this is going to help us for part 2. So in part 2 we want the magnitude of the horizontal components on these hinges acting at E. Oh, so just this one here. Okay, so we are going to take a pivot point as here, and we're going to take moments about F. Okay, so moments at F. Okay, so I normally find it's a good idea just to put all of my forces on. So I have F1, there will be a weight here, and I'm just taking it off the diagram so it's easy to see. So there's going to be a weight there, a weight there, a weight here, and a weight here. Now we only care about perpendicular distances here through the line of action. Okay, so here the perpendicular distance of this force is actually 0. It's directly on the plane of action, so we don't care about this one here. Okay, so this one's going to take no effect. Okay, so here our perpendicular distance from this force is going to be this distance. So and that is 30 centimeters. The perpendicular force, so the perpendicular distance from this mass is the whole distance here. So that's going to be 60 centimeters. And here's also 30 centimeters. Okay, and then this force, the perpendicular distance from this one is in this plane. So we just need this distance from the pivot point. And the question nicely tells us that's 20 centimeters. Okay, so all 3 of these weights are going to cause an clockwise moment. So we'll do moments going clockwise. Okay, and we also need the weights of these, so I just need to annotate on the weights. So this is 0.5 G, this one is 0.2 G, and this one is 0.7 G. Okay, they've got to be forces, so I need to include gravity in here. So we'll start from this one, so 0.5 G, and that is 30 centimetres away, plus this one, 0.7 G, this one is also 30 centimetres away, plus this one, 0.2 G, this one's 60 centimetres away, subtract our F1 force, which is 20 centimetres away, will equal 0. Okay, so after a bit of rearranging there, you should find for F1 to be 23.52 newtons. Okay, and finally for part 3, we're being asked to find the centre of mass from AD. Okay, so AD is this line, so effectively we're being asked for the Y bar value. Okay, so we're being asked to find Y bar. Okay, and our pivot point will choose to be, our datum position will choose to be this corner here, but basically it's this line, because we're not bothering about the X bar. Okay, so there's just 4 point nodes on here, so we'll have this one, 0.7 lots of 0, plus this one, which I haven't labelled on there, that's 0.2 G, plus 0.2 G, and this is how far away from the pivots? That's 20 centimetres, plus, so we've done this one, we'll do this one, plus 0.2, so we take off that G, we don't want G's, they're only masses. Yep, centre of mass, not force, so no G's there, my mistake for that. So 0.2, that is also 20 away from our datum position. And then finally 0.5, and that is 40 away from our datum position. And we divide all of this by our total mass. So 0.7 plus 0.2 plus 0.2 plus 0.5, I make that to be 1.6. Okay, and this is for Y bar. So after you calculate this, you should find Y bar to be 17.5 centimetres from our datum position. Okay, or the line of action of AD, which is what we're after. And that's all we need for question 4.